insulation. In a home, this is one area where I don't think you should compromise, and you should look at the budget in terms of this is maybe an area where we can trim it. Other areas are possibly areas where you can trim. Please don't trim the budget when it comes to insulation. Insulation and windows or glazing, I think, are two of the most important aspects of a building. So cut elsewhere, not in these two areas. I get a lot of questions about insulation, and there are a number of different kinds. So I just want to give you a little rundown as to why we've chosen the insulation we have. In this particular field, in terms of insulation, I actually think it's an easy choice. It'll be controversial. There will be people who contradict what I'm going to say, who don't agree with what I'm going to say, and there'll be people who wholeheartedly agree with what I'm going to say. Once again, this is my opinion and in my experience. Here in Australia, there's a bit of a background. When the insulation was replaced as part of the whole energy side of things, we got extremely busy as a company. We were called in with many people going into hospital with chest infections, and that was just because tradespeople were going up into the roof spaces and stomping around up there and disturbing a lot of insulation and dust in the roof cavity, and that was coming down into the indoor air, and there were some very serious cases of chest infections that took place, and coughs and respiratory issues. Let me start with what I think is the worst way of insulating, and that is with loose fill insulation. You will see there's a lot of loose fill insulation around that is very old, and these days even that is very new. I'm not a big fan of loose fill insulation. It will be pushed by some people because it's often a very natural product. Loose fill wool insulation, loose fill cellulose fibre insulation, just newspaper basically, are spruced as very natural products and therefore a very good thing to use. However, I completely disagree in terms of it being a very good thing to use. Loose fill, for those that don't know, is a loose form of insulation. So it is blown in. Imagine something that's just blowing out all sorts of stuff. Now that stuff can be little torn up pieces of newspaper. So newspaper in tiny little pieces. And the same thing with wool. There's also wool loose fill insulation. And it's just blown in, very natural product, but this stuff is just so prone to affecting the indoor air because it is loose by its very nature. I have found that because it's also broken down, cellulose fibre in particular, if you get any form of water leak, any condensation, any water vapor, any water that is basically in that roof cavity, it will grow so quickly on broken down newspaper. Why? Because it's so easy for mold to digest. It's cellulose, it's newspaper. You put newspaper out in the rain and see how quickly that gets soggy and breaks down, and therefore how quickly mold will grow on it. Why on earth you would have that in a building, I have no idea. But this is what happens. Also, because it's such a loose fibre, you must know that over time in a roof cavity, what happens? There are often mice, there are rats. If there's some water, there is mold. With mice and rats, they defecate up there. So you're talking about their poo. They urinate up there. It's unbelievable how much a mouse and a rat will urinate, just simply running around and urinating as it goes. If we get LED torches and we shine them on with the UV, you can find that it just lights up in terms of the urine, and it is everywhere. So you will get bacteria, you will get mold, you will get the treatments that have gone onto that insulation. So you're going to get pesticide potentially, you're going to get a fire retardant potentially. If there are any binders, you're going to get toxic binders. So when you breathe in any form of insulation that's come into the indoor space from that roof cavity, you're not just breathing in that loose natural newspaper or loose natural wool fibre. You're breathing in all of those things. That's all traveling on that fibre, and that's what you breathe in, and often into the deepest parts of the lungs because they're under 10 micron in aerodynamic diameter. So it's something that is a big problem in my opinion. So loose fill, not a fan because of all those issues. There's rock wool and glass wool and ceramic fibre. These are all the different types. There is also wool, and there are blends of those things. You can get wool and glass fibre blend and so on. And there's polyester, which is a plastic. So those are probably the most common types of insulation bats. So instead of loose, you will then get a bat. They call them bats that look like this. So they come in big pieces and they're simply cut to whatever sizes you need. A lot of them will come in the correct size so that you can just place them into the roof cavity. And then of course with all the bits and pieces and funny areas, you just get a saw and you literally cut this and you place it where you need it. Now glass wool is unbelievably irritating to the skin. Now you will, again, this is plagued with controversy because they will say that the glass fibres now, and this particular fibre is not what they call biopersistent. And what that means is, because it's not biopersistent, it means it won't be like crystalline silica or asbestos or something that's going to embed into your lungs and not be able to move. It will not persist there. It will degrade and will not stay and give you fibrosis, cause scarring the lungs and so on. However, when you breathe that in, you have everything that you're breathing in. So you will have all of the toxic binders and you will have flame retardants. All of these chemicals that I've mentioned that will go into all forms of pesticide that will go into that insulation bat. When that bat flakes off, as that bat starts to degrade and starts to flake off and break down, this will get into the air. Eventually, after many years, that bat can just look like loose fill because it's broken down so much and so easily get into the atmosphere indoors. That happens because on a tile roof, for example, if you don't have sarking that sits under the tiles, which is a wrap of sorts that sits under the tiles, it is very easy, as you can see in this project that we have been through, very easy for dirt and debris to blow in. Now when dirt and debris blow in between the tiles and land in your roof space and mix with all of this, it's food for mold, and it just adds to the toxic load of everything that comes into the indoor environment. My personal preference when it comes to insulation is a polyester bat, and I know that is controversial in some circles. However, I stand by it. The reason being is because there is a very high recycled content in a polyester bat. So when I say very high, I don't want to give you a number because it varies quite dramatically, but it is usually always over 50%, and can sometimes be up to 80% and so on. But it's a high number, and there is recycled content. Yes, there is some virgin plastic in here, which is very far from ideal, but a lot of recycled content is in here. The second thing is the way they form a polyester bat is they thermally bond it, which just is a fancy way of saying they heat it. So when it gets put through a heat process, what happens is the plastic all melts into one another. So that's a good thing in that it doesn't need any toxic binders to make it bind together. This has been thermally bonded and it's heated and then just sets, and it's done. You've just got one big piece of plastic here with a whole bunch of air pockets in here, which is actually what is insulating you. All of those little air pockets, for air to come through here and make it through all of those air pockets and getting through all of that to get to the other side and get out the other side. The thicker this is, obviously, the more difficult that is and more time that it takes. And that's why we use polyester bats, because of those multiple air pockets, because there's not toxic binders, and there's no pesticides that are sprayed on here, as there are on many. These are things that go unnoticed, unmentioned. There are also no flame retardants. My goodness, does everything have flame retardants on? Understandably, fire is a massive problem and is very worrying, but it is not something, flame retardants are not things that you want to be breathing in. No flame retardants, no toxic binders, no pesticides. Recycled content, and one of the most important aspects is it doesn't break down. So often you will buy an R3 bat, R4 bat, whatever it might be, and over time that will diminish. This will start getting thinner and thinner, and collapsing down. You'll see in the photos that we took of the insulation in the house, you can see how much those glass fibre insulation bats, how much they had broken down over just 15 years. It doesn't happen with polyester. As we know, plastic doesn't break down in the environment, a massive problem in the environment. However, in insulation bats, beautiful, because you can put them up there, it'll last 100 years plus. Who knows how long, probably longer. But it will stay and you'll have that same R value. So that is why I recommend polyester. The passive house builders say that at least when they put it into the walls and the ceilings, when you're putting it up like this in a wall cavity, over time there will be sagging that takes place with other types of insulation bats. Polyester will stay like this. 100 years plus, it is staying where it is, which means you're not going to get gaps and cracks as this sags and then suddenly you've got a big air gap here. You're not going to get that. So these are all the reasons for using polyester. Loose fill is even worse. You can imagine how much loose fill will break down and settle down and be non-existent, apart from some toxic dust lying around your house and blowing around in the years to come. So you can imagine loose fill fibre and what toxic dust is just lying around over time. That is not the case with the polyester bat. So those are the multiple reasons why we use it. Basically, how much do you use? However much you can afford would be my recommendation. In the walls, you're obviously quite limited as to how big that wall cavity is, but this is where design from scratch comes into account, where you must design your wall cavity so that you can fit the largest wall insulation bat that you can in there, that you can create an air gap, that you can batten out before you get to the plasterboard wall. Designing that wall cavity so that all of these things fit in there and fit in there comfortably without being squashed. That is going to compromise your insulation. There are so many tradespeople who will go in and squash this insulation, push it in, push the plasterboard on top of it, and everything's compromised. You will start going from R2.7 to R2 to R1.5 and so on and so on. So it's just not the way to do it. The more this is fluffed out and the more this is basically like that, that is so much more effective, so much more air in there than that. So keep that in mind when you're designing your wall cavity. This needs to sit in there beautifully and comfortably. And look at how I'm handling this. Those glass fibre insulation bats that we took out of this property, the poor builders that took them out were scratching for days afterwards. They didn't wear vests. They should have worn overalls. Unbelievably irritating and unbelievably bad for you. So yeah, they were wearing masks and respirators, but they did not have protection on the arms. And the couple of guys who were doing it suffered from it. And you can imagine breathing that in. And the fact that it's not biopersistent and doesn't stay in there in terms of glass fibre, for me, that it just does not cut it. That is not good enough. Yes, that's good that it's not biopersistent, of course, but that is far from a reason why you can use glass fibre, in my opinion. So that is insulation. That is our polyester bats. We use that in the walls. We use it in between. Using on this project in between the window frame and the wall, just breaking off literally breaking off pieces and shoving this in there, and it's going to stay in there because I don't want to use that expandable foam. In the ceiling, we're using R2 bats going one way, that runs that way, then we're using R4 bats running the other way, so that they crisscross, laminate if you will, they crisscross like a lamination, cross lamination going in different directions. That will create a tighter seal, and that will be our insulation in the roof, keeping us warm. So please don't cut corners or trim the budget when it comes to insulation. These bats, polyester bats, as thick as you can afford, should go in everywhere. CSIRO have done a lot of research, and they say, look, you get a lot of gain up to R3, maybe 3.5 odd. As soon as you start going over that, they say, look, for what you're paying, you're not getting as big a benefit. However, the more you can put in, the better it can be. But just keep that in mind. All right, these are my beautiful boys, my twin boys, Sebi and Ethan. All right, did you say hello, boys?
Hello.
Okay. Now I want to demonstrate to you why we've used polyester insulation. Let's take a piece out of here of what we've put in. Now, boys, can you feel this? Put it on your face. That's it. Does it feel very scratchy and itchy?
No.
Is it stinky?
No.
No? This could be used, this is the stuff that's used for pillows. And I'll explain in great detail why we use this, because it is so healthy, it is so non-toxic, and there are a number of other reasons. But this is why children can handle this particular material and not have any issues. All right, boys, thank you. Right, let's look at some photographs now. I'm going to talk you through just some photos of our project, what we found in relation to insulation, and how we went about trying to fix those problems, so we can give you as much information about that as possible in relation to membranes that are insulation, Gutex wood fibre boards above windows and doors, as well as obviously bulk insulation, which we've spoken about a bit already, but just showing you on site what it should look like. So what I'm going to do here is just bring up photographs so that I will talk you through those photos and tell you what's going on as we go. So photograph number one, here we're looking at bulk insulation bats, the polyester bats like we've spoken about that we used on this project. We've taken all the old nonsense out and we have put all of these in. This is the polyester bats, and what a wall should look like without any gaps. This is the main reason for showing you this photograph, showing you that you can see your noggins and your studs there, and you can see how the insulation bats have been cut and placed in there, not squashed, fitting in without collapsing all of the beautiful air pockets in between, and not leaving big and noticeable gaps between everything. So everything just fits snugly, that's all. So cutting it to the correct size and fitting it in snugly, that's all you need to do. That's the key. You can see that there's a power cord fitting out there. Don't forget to pull those out, otherwise you go digging behind everywhere. So make sure the power points, light fittings for the ceiling insulation, all of that cabling is pulled through so that you're not digging for it later. But that's what bulk insulation bats look like in a wall, and what they should look like. This next photograph, this is to show you that when we have the ceiling insulation, which is that white polyester insulation, meeting what's going to be the wall insulation, which is the darker insulation bat, basically if we have something coming across the ceiling here in terms of insulation, and we have something coming up here in terms of wall insulation, what happens at this little gap in between? Often it is just left, and that's a big gaping hole where cold air can come in. So what we need to be very mindful of is, as the ceiling insulation ends, as you can see the white insulation bat, we then get a wall insulation bat and we bend that around the corner to meet with the wall insulation bats that we showed you in the previous photo, so that the insulation is continuous up the wall around and across the ceiling. There are no big gaping holes and gaps. That's the main reason for showing you this photograph, to show that it needs to be continuous and neat and thick. Take your time, like everything that's done well on a building site. Don't rush it. Take your time. It's done once, then it's all sealed up. So just make sure it's done properly. So that's the reason for showing you that one. If we move on to the next photograph here, you'll see that this is where we're going to discuss, and we put a lot of detail into discussing what we do above windows and sliding doors and so on, your glazing. This is a photograph where we have taken out a big sliding door glazing as well as a big window, and just trying to show you above that window and door how they use this fibre cement sheeting. Didn't have brickwork, so, and how we're going to try and address that now. You can see that there was no insulation in that cavity wall above the framing. You can see the timber framing, but there's no insulation there. And then you can just see the fibre cement sheeting, thin nonsense rubbish stuff that is just clad onto the outside of the building. When I say clad, I hate sheeting of any kind, to be honest, cladding on the outside, because when you see someone putting the outside of your house together and they've got two things, they've got a nail gun in one hand and they've got silicone glue in the other hand, and literally the whole outside of your house has got little brad nails going in, and you've got glue desperately pasting it together. Looks great for a while, but over time what you're going to find is that those nails are going to start to come out as very harsh sunlight, wind, cold. As these temperature changes and moisture levels change, things move around. That means the nails are going to come loose. That means the glue's going to dry out and also come off, and that's exactly what happened at this house. 15 years, that fibre cement sheeting was beginning to flap around like crazy. You could see it, the nails coming out and it pulling up from underneath. You could see where two sheets were joined. They started coming apart. Water just gets in. Even if it's small, run a bit of water down. Water gets in everywhere. That's the nature of water. So it needs to be absolutely watertight. And believe me, fibre cement sheeting board over time is not watertight. And then try and find the source of that moisture. Very difficult without getting quite destructive. So that's what I wanted to show you. Look at this fibre cement sheeting flapping around. That is literally, yes, it doesn't have anything underneath it, but that is what it looked like after 15 years, started coming apart to that degree between the sheets. Maybe that's a bit exaggerated. It wasn't quite that bad, but it was close to that. So that's the reason for showing you now how we're going to address that problem. If we go on to the next photograph, we're addressing it by using a product called Gutex from overseas. This is a wood fibre product. Basically, they've taken the offcuts from when they're milling the wood and cutting wood. They take all the offcuts, compress it under very high pressure together, and the wood fibres, this is what bonds them together, this very high pressure and the natural resins coming out of the timber. Similar things are done with the DuraPanel here in Australia. Very nice product, wonderful product. Again, just compressed under enormous amount of pressure to produce such a well insulated fibre. If you look at that, for cold air to come in, warm air to leave, it's got to get through all of that. Very dense, very good insulator. And the white coating on the top there, that is a pre-rendered finish. So this will come pre-rendered because we're rendering the house with our beautiful natural lime render. That was a perfect product to choose in this particular project and case. So that's the product we are now going to cut to size and put above the windows and glazing. So if we go on to the next photo, it's just showing Reese cutting that board to size to fit above a particular window, wearing a lot of PPE, hearing protection, eye protection, respirator protection, because it's wood. And wood, hardwood and softwood have different exposure standards, but they're all particulates. They must all be dealt with very carefully and not breathed in. Eyes are very important to protect at the same time. And you can see it's all done outdoors. You may say, well, that goes without saying, but I can tell you a lot of cutting often just happens indoors and not outdoors. It's raining, they're on a bit of a time schedule, and so all this cutting happens indoors. Please avoid cutting indoors. It's often done in the garage then, but try and avoid, garages are often open they're connected to the house, and that can get into the house and onto all your new insulation. Please just try and do these things outdoors if possible. You may think that's obvious, but you'll be surprised what happens on site. So the next photo is just cutting it again. You can see the wood fibre just coming from that, the cutting of that board. And the next photo, when we go on, shows us doing the preparation above a window. So you can see that everything's been taped up with our Seeger tapes of different kinds. You can see the Seeger wrap, which has gone over the frame. On the other side, on the inside of that wrap, you will see that there will be insulation bats running up as per normal in your wall cavity. Then we put that wrap over there. Then they put these small square timber battens. So that's to batten it out so that we can create a cavity. And you'll see that there are some little packers. You can see a little green one on its side and another one. That's just to try and get things even. So we want it nice and flush and straight and even. And sometimes if things are not straight, we use those things to try and make things flush and straight. So that's a very important photograph. The next step is to then put up these timber pieces. You'll see one on the top, one on the bottom that are now been screwed into the battens. The next photo I think should show it more clearly. So there's a bit of a close-up showing you how we've attached those timber pieces onto the wood battens. This is all above glazing or sliding doors and so on. Then if we go on to the next one, you'll see that we've taken insulation now again. So we've put that into that, basically that gap and that cavity we've created. So we've got bulk insulation on the outside where we're looking at it now, and we've got bulk insulation, then we have a membrane, and then we've got bulk insulation again on the inside. So that's a lot of insulation. And then if we look at the next photo, you can see this is the Gutex product that has now been cut to size nicely. We have then put in some screws, which you can see there, that's how it's going to attach. And you can see the rendered finish. So this is just a nice photograph of showing you this wood fibre product that we're now going to be putting in above the windows. The next photograph will show you here that it's gone in, and you will see how it's snugly fit and nice and flush with the brickwork, allowing that for when the render occurs, that the render can render on top of this Gutex product and then render straight onto the brick, and will have a very flush and even finish. So you will not know that there is brick on the wall and then suddenly above windows we have this Gutex product. You will just see a nice flush rendered finish. It will all look like one product, like it's all brick, the way it should have been. Even though we didn't choose to go lintels and brickwork and so on, we chose to use this product. Hell of a good insulation, and it doesn't look like we've chosen anything different. And it's a nice photo in that you can see how flush it sits onto that timber piece, how they then use tapes to then pull everything together and make sure everything's airtight as well. So that's an important photograph in understanding how that's done. There you can see that now the tape that was above the window will now be taped onto the underside of that Gutex product, and then the renderer will do his thing and make it all flush. So now you can see the difference between how we filled up above windows and doors there compared to the result that we had before. There you can see on the window, because we're putting European windows into an Australian window reveal, it's we've had to use some foam. Not an ideal product, it's something I try to avoid, but there was no getting around this one. So as you can see, just on the outside, on the reveals there, we've put a foam product and taped that over. And that was more of a challenge for the renderer. A lot trickier to render around a foam product onto brick than it is with that pre-rendered finish on the Gutex wood fibre product. But on the sides of the windows and the glazing, that's what we had to do. And again, that will seal up that gap. And even though it's taped and we've put insulation in between the gap of the window and the wall, we've put this foam in there as well to take up all of that space. And obviously foam is a very good insulator, but not something I like to use at all. But we had to use it here, the styrene, unfortunately, but that's just to show you what that is. And there you can see just a close-up again of what it looks like when it's finished. And now it's time for the renderer to come in and work his magic. But that's how we did it in this particular case. All right, so this is this is something that's a bit tricky to try and explain, but let's see how we go. Right, we have taken out our old windows, our old sliding doors. This is one area where a door and a window have come out, and we're now going to replace it with our triple glazed windows. I just wanted to run through this, where this is our fibre cement sheeting board on the outside, where to save money above above every single window and door, they have put fibre cement sheeting. That's to save some money on not putting a lintel here and brickwork. So we're not going to put in lintels and bricks. What we're doing is taking this fibre cement sheeting out, and we're going to put a product called Gutex in. So again, we will photograph and show you that, but I just wanted to show you this is coming out. The Gutex is going in here, so we will pull this out. We're going to put in a beautiful Gutex product, which is recycled timber fibre that's as thick as this in insulation, which we've shown you. That's going to go in here for all our insulation above. It will have a board on the outside that will be rendered. It will look like a rendered wall, and there will be beautiful ceiling, beautiful insulation, and this revolting thin fibre cement sheeting will be gone, with wonderful insulation through the Gutex product above it, and then our triple glazed doors in with all of the taping that you've seen in all the Seeger sealant tapes around it, and then of course the insulation bats all around that. So we're insulated above the windows where there was just fibre cement sheeting and a wrap. Absolutely almost nothing in terms of insulation. Now we will have full Gutex and all of the tapes sealing everything off, and we're going to show that installation. But just giving you that detail here, many properties will save money by putting this thin fibre cement sheeting there, and just a wrap, no lintel, no bricks, to save that bit of money. It's not something that should be done. Please at least go the bricks on the outside, get the lintels in, get the bricks in. Don't do this cheap shortcut, which is done on a number of homes.
Just getting it flush behind the fascia, packing our Gutex out flush with the brickwork so we can get a nice clean rendered finish. Screwing our waffle screws in, not to over tighten them and break too much of the render. Making sure we're flush with the timber piece that we've already previously put in.
So you've put up this Gutex
Yes.
above the window. We've got the tapes sitting
Yep.
nice and flush out from the window here. So we've got the window frame, we've got the Seeger tapes sitting out here. And what's the width of this Gutex?
85 mil with the render.
85 mil with render, so
Yep.
it's
So it's got
significant.
about a 5 mil render skin on it already.
Okay.
So it's pre-rendered.
And so the renderer, when this is stuck to the underside of the Gutex, is that correct? Then they're going to render right
Straight.
under here, straight through and up to the frame. So we're going to have a nice tight
Yeah.
render seal, and then we're going to have the aluminium frame, and everything's basically covered in this tape,
Yep.
the thermal break
Yep.
over there, even into the plugs.
Yep.
How often do you see this Gutex used here in Australia? Because I've never come across this product.
It's not really seen as such. Only really I've seen us use it
Yeah, yeah.
on majority of our new builds.
Yeah.
This is the first time I've used the product on a retrofit house, which is good to see it being
Yeah,
used.
right.
Yeah.
Yeah.
Being this pre-rendered one as well, in this circumstance with the rest of the house being rendered, it was such a good product to use.
Yep.
I couldn't think of a better product to use.
Yeah, because before, as we photographed before, above these windows all we had was fibre cement sheeting. How thick would that have been? Very thin fibre cement sheeting.
Yes.
No insulation behind the fibre cement sheeting.
No.
And then plasterboard
Yep.
on the inside.
Yep.
So now the big difference is we have all this Gutex, we have the battening, the timber battening,
Yep.
we have all of this taping,
Yep.
and we have the insulation bats on the other side of that,
Yep.
and an airtight membrane, and then battening, and then the plasterboard on top of that.
So now that we've covered the insulation bats to a great degree in the walls and as well as above glazing and so on, let's take a little look at the membranes that we'll go over, because they form part of the insulation, an incredibly important part of the insulation. If we look at this photograph, you will see that it's a nice one to show the ceiling and what we've done here. So if you look there, the white insulation bat is our ceiling bat. The blue straps just help to hold that up and support the insulation bats. That's what the blue strapping is. And of course we've got 2 rows of insulation bats, as we discussed. We've got an R2 insulation bat going in one way, and we've got an R4 bat insulation going the other way, so that you can see, and we'll have photographs of that too, but that's what we've got above, that's what you're looking at. And then we have our membrane. They call it an airtight membrane. It's not airtight, it's just a lot tighter than the other membranes. But certainly this is more of an airtight membrane that is wrapped along the entire part of the ceiling, again coming down and running all of the walls that are around the perimeter. Obviously we don't do the internal walls that have no access to outside, but all of the outside perimeter walls, this wrap is under the whole ceiling and down all of the walls on the outside, so that we are nice and tightly wrapped. So there we go, that's what that looks like, just so that you can see, and we've discussed in a lot of detail how we don't like to use staples a lot. That will be discussed and shown in footage, because staples make holes in everything, and where they do use staples it's taped up a lot, and we use a lot of double-sided tape to adhere that. So that's a photo of that one. The next one shows, again, just down the hallway, just showing you as this is being applied, what an enormous job this is, and why passive houses are just a lot more time consuming. You can see what's involved in running all of this membrane, and there you can see there are no staples. There's double-sided tape running all down there. That's why you don't see staples everywhere, where you just see slightly lighter marks, all double-sided tape used. And you can see we're trying to minimize the tape that needs to join all these membranes together. It's like a massive, massive, most difficult jigsaw puzzle, if you ask me. But that's to give you an idea of the membranes that are now put under all of the insulation bats. If we look at the next photograph, you will see that This is a sliding door cavity. It's just showing the top of it. Now, when we did the smoke gun test in the beginning to see where all of the major holes were, sliding door cavities are always open up to so very often are open up to the roof cavity. Now you can see that the membrane is running right across the top of that sliding door cavity. So we now don't have a big air gap going into the roof cavity. We do that smoke gun test, we can see it's not going to be all going up into the roof cavity. There's not a big hole there anymore. This membrane runs right across everything and seals up everything. That's important because it was a major issue when we looked at it previously. The next photograph just shows you in quite a lot of detail. You'll go, what on earth is that? Basically the heat recovery ventilation ductwork. You can see how much thinner it is. You don't have these big ducts like we're used to in ducted heating systems and so on. That grey duct is the heat recovery ventilation duct. And you can see how we've treated it. We have put it below, and this is really important, all of the ceiling insulation bats, because if that ductwork is on top of the insulation bats in the roof cavity, basically, when that roof cavity gets very hot and when that roof cavity gets very cold, the air in that duct gets very hot or very cold. So we need to insulate these ducts that are holding this precious air that we're trying to recover the heat from and that we're bringing fresh air into and so on. So it is very mindfully placed under the insulation bats, and you can see here that in areas where basically we've taken it like a massive doona and just placed more insulation around it and basically wrapped it up tightly and used straps to hold it up, and then we just have ducts running everywhere underneath. A big job to do this, but it must be done this way to make the heat recovery ventilation system a lot more efficient. If you're going to put all your ductwork into uninsulated spaces, it is not going to be as efficient as you can imagine, because as those uninsulated spaces get so hot and cold, so will your air. So that's just to show you the degree to which we have gone to in terms of insulation, particularly protecting ductwork. So that is the membrane stuff that I wanted to show you. Now let's look at the taping, which is the enormous job. This is a photograph of the extractor fan, so the range hood above the cooktop. You can see that in our particular case, that's a much bigger duct. We will talk in detail about the range hood and the extraction we use and how it's quite different. But yes, that's a big duct for a nice big draw. And you can see how much that is taped to prevent anything from coming through and any gaps and cracks. And the taping that went on all around that. In the background, you can see the heat recovery ventilation duct, one of the supply vents. That's what that looks like. That's going to be supplying the filtered fresh air that's had the heat recovered from it. But this is the range hood, and just showing you what a job it is to tape around all of that. If we go on to the next one, you can see around a window on the inside, you have an enormous amount of tape that tapes the membrane to the window frame, ensuring that there is no gap, and also sealing that gap between the window and the wall. That is all taped through. If you looked at when we stripped out the windows before, you took the architrave off, and that's what happened. You could just see straight outside. There was nothing protecting you from the outdoors except for an architrave. Here we have insulation in that gap, and we have tape on the outside, and we have tape on the inside, and we have render on the outside. There's an enormous amount that is protecting those gaps and weak points around the windows. You can spend a fortune on windows. If they are not installed properly, it is going to take away from all of that money that you have spent. So how the window's installed is incredibly important. So you can also see that when we have a power point coming through below the window and to the right there, all that green taping, they tape all around those holes as well. So that any cables coming through are fully taped around to keep it airtight as well. So a lot of time on the site was spent taping, a lot of time. Here it just shows you actually how neatly it was done. Here is a wall and there's the ceiling, and you can see how few joins there are, how neatly and difficult this is, but how beautifully this has been wrapped with as few joins and tape as possible. A very impressive photograph, that one, when you actually try to do this kind of work. This photograph, that little piece of yellow taping, is where they've had to use a staple. So where you have to use a staple to hold the membrane up, they then tape all around that staple as well to make sure that that hole is as airtight as possible. So this is the degree to which they go, that you might not realize why it's important to show these photos. Again, showing how nice and neatly you have an overlap. You see that dark white section towards the top. That is one membrane from the bottom coming with another membrane from the top, and it's important that they overlap at those joins, and then taping happens over that. All very nice and neat. And there you can see the double-sided tape down the bottom in the middle as well, so that the staples required is minimized. If we go on to the next one, also shows that when we putting up the plasterboard ceiling, you can see that basically these furring channels and the metal, even when they screw that into the timber, that's going to pierce the membrane as well. So little rubber seals are used in order to basically, another product that is used, there's another Sega product where basically that screw, where it does go in and is going to pierce the membrane, has all of this around it so that that hole is as tightly sealed as possible. So it is very mindful that any screw, any nail, anything that's going through a membrane, that hole that's made is protected and insulated. And this last photograph is a photograph again of here where they've created a nice recess. This was done in some light fittings so that we can have a gap in the light to fit the light fitting in. It has a little well. Some of it was done sometimes for PowerPoints and so on. But there it shows you that where we do create something for a light, for example, it's an enormous amount of work to create a nice little well for it so the fitting can fit in. And of course, we're not using something that generates a lot of heat, otherwise that would be an issue. Those days I think are gone. But yes, you can see the amount of taping and effort there is for each one. Okay, Rhys, we're now going to look at your work in terms of the membrane and all of the taping that's been done. When Joseph was here and we did the blow door test, he was really impressed with your work over here, showing that where these two membranes overlap, we can see that it's perfectly straight and the overlapping is perfectly in line. But this down here looks like some double-sided tape. Can you explain why that's been put there?
Once again, it's another Sega product called Twin-It. And what this allows us to achieve is no staples through our membrane, where there's not going to be any taping.
Yep.
Which means less taping for us to do afterwards, which means less chance of us missing a staple.
Yeah.
Because in our experience, if you leave a staple as is, when the house, even just from construction, the membrane blowing in and out, and then especially when you do the blower door test, you're really bringing in that membrane and it has a chance for the staple to rip.
Okay.
And if you get just the slightest pinhole, it's going to change everything.
That's where they'll come in. So literally, where you've had to use staples, you've gone over and taped over every staple, and try to minimise staples by using all this double-sided tape.
Yep. And we take advantage of the lines that Siga's have given us to keep everything straight, and then that way we know that we can staple under there. See, as there's a staple there.
Yeah.
And once that gets lapped over and that gets taped, then that staple is not going to be an issue to us.
Yeah, wow.
So we just maximise everything that they give us.
And that's why we're putting this battening out as well, so that nothing can pierce this membrane.
Yeah.
So they were saying, though, when I was chatting to Joseph, he was saying that the biggest risk is the contractors that now come in after we've put this all up. We don't want to pierce this membrane in any way. So you've got that gap. How many mil have we got once we've battened out and put the plasterboard on?
A total of 45 mil to the face of the plaster.
To the face.
Yep. So we put a 35 mil batten on plus 10 mil.
So we've got an electrician who's going to come in and who's obviously going to cut out where the switches and the power points and that go. That can obviously, if he goes in too much, he'll cut and pierce all of your work done here.
Yep.
So he mentioned something about their saws and basically taping the end of the saw just as a precautionary measure so that as he goes in, he doesn't pierce that membrane.
Yep.
But I guess he just has to be used to doing a very shallow saw cut.
We like to get the electricians to cut the point off the end of their saws. Yeah. So have 2 saws, one with a point to start the cut, and then the next one blunt tip, so then you know that you don't really have that tip there to go through.
Okay.
And if it's blunt enough, it can just touch without piercing.
Yeah.
So
and obviously if anyone does pierce anything, to just tell you straight away. So it's not a problem, don't freak out, but let's just tape it up again and fix it up. So plasterers as well, although they're going to go into the battens, that's why they're there and don't have to go into this membrane. But that's it. And also something Joseph mentioned was how there's less tape than what he normally sees in other jobs, especially on corners, where he mentioned you'll often just see a whole bunch of tape, and that's often where things they're more detrimental in terms of the results that they get if the more tape you use. But I'd imagine it's quite an art to try and get membranes to all come together in corners and not use a whole bunch of tape. Like, how do you get so many different pieces of membranes to come together and minimize the tape? I don't even know how.
It's just an art. It's literally an art. Like, we've just over time been able to.
It's a skill learnt. I was chatting to Dale and he said, that this has just come with experience. That maybe in the beginning there was a lot more tape and you just got better at it.
Different ways that you thought that, this will be fine, but as you go through it, it's like Joseph said, less is more. So you try and eliminate the overlaps of different membranes coming to each other and just think about it more of what needs to come down first, what needs to go there first, so you can seal up. And
so it's a huge skill, and everyone thinks, just put some membranes up and tape it up. That's a very big skill that requires a lot of experience. It's something I've noticed just out of watching you guys and seeing Joseph's feedback. But
it's a fiddly long process, but 100% worth it.
and something I've noticed you mentioned as well, Sega has been around since, I think, the odd 1950s, did you say?
I think it is, late 50s.
A long time, basically, whenever it is a long time, family. And you've mentioned that even after decades, possibly even up to 50 years or so, where they've gone into buildings where Sega tapes have been used, saying they're still adhering. Wow. So that's fascinating, because that's my biggest fear, that man-made adhesives, a nature of glue is that it will always dry out in time and then it will come off, all glues. So to know that in my lifetime at least, that this, when pressed on correctly, and that's something else Joseph spoke about, that you need to press this on hard, and that can make a big difference if you're just lazy on not pressing it in.
If your fingers aren't burning, you're not doing it right.
Yeah, right. So great job, and I just wanted to show how tricky this is, and it's not as simple as it looks. And even though it looks like a bunch of tape, this is done unbelievably well and minimized in tape.
For being a retrofit as well, for us this is a lot of tape. Like on a new build, there'll be a lot less. Like in these junctions and everything, it'll be even more minimal.
Oh, really?
Yeah.
Why? Because you can.
Because we can preempt what's going to happen before the internal walls go in and everything like that. So we can put backing strips of membrane behind there, the T-junctions and everything like that, so we can visualise what's going to happen before it happens and achieve a better goal.
So like all retrofits, just more difficult.
Yeah.
But we've got a great result in this one. Joseph did mention that although we got on average between the two tests around just over 0.5 air changes, where he says that it can get potentially a little worse after we've put all the board and the plasterboard up, which I thought, what's he talking about? Because it's a lot more blocked in, there should be less. But he mentioned all of these issues with the trades and tearing and all of that type of thing. So let's hope we don't tear everything and we can stay on top of the electrician, which he mentions around 80% of the reasons why they're holes, and the plasterboard. And we've got a really good electrician, very mindful, so let's hope we can stay on top of all of that and see what the result is at the end. Brilliant.
Thank you.
There is some footage now which we'll show in relation to the membranes and the taping and using staples and double-sided tape and so on, that we took on site, so that you can see exactly what that's all about. Now, lastly, I'd just like to speak about, when it comes to insulation, I just want to speak about this amazing product from Seeger again, which is used to block holes that you put into any timber work. We'll show some footage on this as well, so that you can see it live and what it is. But basically, I just want to run through a couple of photos before that footage. You can see here that we have pre-drilled some holes into some timber work here, and these are battens that are going to go onto the wall for the plasterboard on the inside to be adhered to. So basically we created basically a second framework, because you have your timber wood frame, and then when you batten out, you're creating another air gap and places to put electrical stuff and so on. But you've got to do it around the entire ceiling as well as the walls. So you are almost framing out the house again, in essence, with battens, but you're basically, to me, it seemed like it was like putting another frame on the house, just internally. But here you can see that's what this is. This is now going to be the internal battens. The plaster board is now going to be adhered onto these. So they pre-drill these holes. I don't know, I found this remarkable. And then into the hole they put this product called Prima, which you can see the photos of this particular product. This Prima is this blue gooey stuff, basically, that never really hardens. It stays malleable for the life of the product. So it is always soft and malleable. So this is what is then put and pushed into all of those pre-drilled holes. A lot of work. I can almost hear everyone going, my goodness, are you joking? What a lot of work. But yes, that's put into every pre-drilled hole, as you can see there. And then it's basically when the screws, here you can see him now screwing it onto the wall panel. Now that Prima has been put in there. And basically when that screw goes in, it just squidges, not using very technical terms, but it basically just squidges all in and fills all of the air gap around this hole you are now making by drilling through the timber to adhere it onto more timber, basically, but to latch it on, so that there you're piercing that membrane again. So they want to be 100% sure that they've tried to seal whatever holes they are making in there. So there you can see him put it together, but this photograph is probably one of the better ones. If you look at that screw in the timber, now this is below the window frame, you can see that big metal screw. If you look at the yellow tape directly above it, you can see what just looks like a dirty sort of mark. Now that dirty sort of mark is the Prima product. It has sort of squidged through that hole and sealed everywhere in that hole, but then also sealed. As the screw has then gone through the back of it, it has come through and it has sealed that. So this just shows you how this amazing product, where it's just sort of squidgy stuff, has filled up any gap that has been made by putting a screw through the timber and piercing membranes in the timber and so on, and keeping it airtight. It's amazing. I don't know. They looked at me when I went crazy and about this and got so excited and thought I was mad. I think it's one of the more amazing parts of insulation and sealing up a house. Here you can see it more crudely in this last photograph, where basically plumbing pipes, pushing that through, they use the same Prima product. So they will put that all around any holes that are there. I don't like expandable foam. I refuse to have it on site in any way or form. So a lot of the time, expandable foam are used to fill up gaps between windows and doors and this type of thing if you want to keep it airtight. That stuff is so toxic. That is why people wear full PPE applying it. I just don't like it. I said no matter what happens, there will be compromises or there will be other things done, but we are not using that expandable spray foam on the site in any way or form. So there are certain things where we've compromised here, certain things which I feel just cannot be compromised on any level. That's one of them. And having this product by Sega, this Prima, just fills that in, and it will not go hard and dry out. It stays malleable and soft for the life of the product, so that that goo is basically always goo and sealed in there. So that's just what I wanted to show you. You can see some footage now where you'll actually be showing how it is applied and telling you a little bit more about it, but I just wanted to go into some detail there. So that is insulation. I hope you've got a lot out of that, a lot of information there. So hopefully you won't make any mistakes and just take from it what you need.
Reece, so explain what we're doing here in terms of what this batten is for and where it's being used and what you've done over here.
Yep, so this batten is our plaster batten on top of our wall membrane.
Yep.
Which serves so that there's no penetrations put through our internal membrane, and also a service cavity if need be, where like all our power supply comes through our membrane. It has an area for the electrician to fit off everything and push it back into.
Yep.
The product we're using so we're pre-drilling all our battens, and then we're putting this product called Prima, which is another Sega product.
Yeah.
They have a product for everything.
Yeah, see that.
So we're literally just putting that over every single pre-drill that we've done.
Yeah.
So then when our screw, we use a 100mm batten screw. Once the screw goes through the batten, it gets bounded up inside. So then
literally create a seal around everything.
Yeah. So that creates an airtight seal. This product never sets hard. It's always malleable, so it's always going to keep its consistency and airtight seal.
Yeah, and in your experience, some people say, well, if you're going to be screwing this on, that this is so flush with the membrane, that having this flush up against the membrane will be enough in terms of not needing this. But in your experience,
we choose to do this.
Yeah. Okay.
Just as an extra benefit for us to know that we're creating the best possible airtight seal we can.
Because that's a lot of holes. I mean, so it's a lot of holes right through the house putting all this battening up. And it also create another air space, another air gap in terms of insulation as well.
Yeah.
Brilliant.
Thank you.
Well, I'd like to talk about another insulation product that I came across after we'd finished filming everything, but something I wanted to discuss in more detail. So I've come across a company called Life Panels. Had a lot of conversations with James, a very passionate and incredibly helpful director of Life Panels, who is bringing in these wood fibre insulation panels. So I'd like to thank him for that. But basically, and he's here in Australia bringing these panels from Europe with an end goal of trying to get it made in Australia. Wood fibre, unfortunately, is something that is quite hard, becoming harder and harder to come by, and so the amount required and the investment here in Australia can be tricky, but James is trying very passionately and hard to bring that in and make that happen, but at the moment it's coming from Europe. So I wanted to discuss firstly two types of insulation product that they have, but also allude to the fact that this wood fibre product is something that can replace plasterboard too. There is a product that is around 10 mil, 9-10 mil thick, and is the equivalent of replacing a plasterboard wall, which I think is pretty exciting. James is not bringing that in currently when we're filming now in 2021, but hopefully that will be a product line that can come in. But for now, the insulation products we're talking about are these wood fibre insulation products. Now, wood fibre is something that there are wood chips that you can get from basically milling a piece of timber, and all of the fibre and the falls onto the floor and the wood chips, and you get that and you're using that, what would be a waste product, or you get wood chips from timber elsewhere. But we're talking about pieces of wood basically, and chips of wood and fibre of wood that is compressed together. I'm going to talk about two different products here that they have. One is this wood fibre, and I'm just going to lean over here to make sure I get all my numbers correct. Here we have a wood fibre board actually, before we talk about the board, let's talk about what we know, and that's the insulation bat. So an insulation bat, this is 90 mil in diameter, as you can see, and it's very dense. You can see as I pry that open, maybe this bigger piece will be better to see, and you can see how nice and dense and how rigid it is. It's really rigid. It doesn't just collapse down to nothing, which means it's not going to sag over time and will hold its weight. So like the polyester bats, which I've alluded to that I really like, this will be similar in terms of its rigidity and longevity because of how rigid it is. Not going to, you can see how I can barely bend that. For this to collapse over time is not going to happen very easily. So this insulation bat consists of 80% wood fibre. So it's generally softwood, pine that's used, and it's 80% wood fibre. The other 20% is made up of binding fibres, water in the form of wood moisture, so no issues there, and some ammonia phosphate, 6 to 8%, that is added as a form of flame retardant. So the ammonia phosphate added, I'm not too perturbed about. The water obviously is not a big deal. The binding fibres, basically if I talk you through the process, they pulp all the wood chips, then they add this ammonia phosphate as a flame retardant, then they dry the fibres, and then they add the binding fibres, and then they melt the binding fibres in hot air through an air drying furnace, and then they cool the binding fibres in cold air through an air drying furnace, and then they trim up all the boards. So what that means is these binders, it's plastic basically, a form of plastic, little pieces of plastic that are put into the air together with all the wood fibres, and then that it's all compressed under high pressure and put together. So that plastic that melts, and binding fibres where we have 3 to 8%. So it's not a large percentage when you think that the moisture is 4 to 8% and ammonia phosphate is 6 to 8%. So it's a wonderful product. It's not 100% wood fibre, but it is 80% wood fibre, moisture 6 to 8% that comes in the form of wood moisture, and then you've just got the binding fibres of plastic and some ammonia phosphate. So generally a very, very good product, and a lot more dense, a lot more rigid, and something that is quite natural. In terms of the next product that they have, let's put that there. This is a much more rigid board. So not so much an insulation bat, but a board. And these, as you can see, like a jigsaw puzzle, just fit into one another, and you can place these wherever you want to. And this is really rigid. I mean, this is hard like a wall. It's not as flexible, if you will, as the insulation bat, which is still very rigid. More, I'd say this wood fibre board, I wish you could feel it, but basically this wood fibre insulation bat is very similar to polyester in its rigidity, but more rigid. And then we have this board, which is very rigid. This is more like a solid wall. I'm a big fan of this because this, if we look at the makeup, it is 95.2% softwood. Some of it said that there is a little bit of hardwood potentially mixed in with the softwood, but it's basically mainly all softwood. Instead of 80% wood fibre, this is 95% wood fibre, 95.2. So mainly wood fibre board, and a lot more rigid. There's polyurea, which makes up 0.4%. So we do have a little bit of paraffin at 0.7, so next to nothing. I don't think that's a big issue. And then a polymer concentrate, 0.14%. So very little. Again, if we talk through the process, there's the heating of the wood chips under pressure. Then they dry the fibres in a flash tube dryer, and then they spray the fibre with resin adhesive. So that'll be that polyurea, and then they scatter the fibres to form a very even mat. So again, you're using basically what sound to me, in my understanding, is a little bit of plastic, just to bind everything together and heat it all and bind it all into this unit. But there's no, when it comes, because this is so dense, it looks like they don't need to apply a flame retardant here. So no ammonium phosphate or any form of flame retardant applied to this, because when you put a flame to here, I would imagine that it is not going to come out, and there's all sorts of documentation to that regard. But I like it because there's no flame retardant at all, and it is 95% wood fibre, and it is so rigid. This is going nowhere anytime soon. So it's not as flexible as you can fit in, and you've got to cut it. It also doesn't flake as much. I'm basically handling this product, and if you can see here, there's quite a lot of dust and fibre that comes from it. So that the only disadvantage is that when you do cut this to size, there's a lot of wood dust. So obviously you need to be mindful of that in terms of exposure standards and wood. But this is similar to the Gutex product we used, if you've seen the other footage, that we placed this nice wood fibre board above all of our glazing. So I really do like this product. It's a wonderful product, and it's 95.2% wood fibre. So that is that product. I wanted to talk you through, you would have seen, if you've seen the other footage, you would have seen these screws that are used to go into. We went into quite a lot of detail showing how this is basically installed, and how we use our little foam inserts, even from a passive house point of view, even so that there's not a thermal bridge, because there is a metal screw head in there. So what we do is place this, unfortunately, styrene, a nasty little styrene plug that goes in there, but it's very little. So that's just to cover up that air cannot come through and hit that cold screw, that we're going to have a thermal break there. So that is that. I just wanted to run through then as a summary. It's very high density, so from that point of view it's great, high density product, and will give you sound insulation as well. So this is a wonderful product to put in as a wall behind what I wouldn't use plasterboard, I would use the wood fibre board as wall, and then use this behind that. You're going to have incredible soundproofing. You're not going to have echoey plasterboard, so that'll make a big difference. As well as obviously high density will help enormously with overheating control. And then there's low thermal conductivity. So that means, like metal has high thermal conductivity, this metal, for example, a screw is going to get so cold and so hot. To summarize, so let's summarize. We have the fact that this is high density. So high density means that we'll have great soundproofing, and we'll also have great overheating control. Instead of echoey plasterboard, if we had great wood fibre walls, basically, instead of plasterboard walls, and then we had this, a beautiful board sitting behind that, it makes such a difference in the acoustics in a room. I didn't think it would be that big a deal, but as soon as you put things in a room that are not echoey, that are much better acoustically, what a difference to the sound in that room. So low thermal conductivity, you're not going to have something like metal that gets cold so quickly and hot so quickly. You're not going to have that. You're going to have something where it takes a long time to heat up and cool down. So an excellent insulator. High heat storage. So what happens is when we get a lot of hot days, and say this is your roof insulation, you've got a ColourBond roof on top of here, that heats up enormously. That heat transfers to this product, And it will take a long time, a much longer time than any other material, besides the nasty styrene and so on. It will take a long time for that heat to get out of there, and it will store that heat for a significant amount of time so that it doesn't get through to there. That is good. It's the same thing with the cold. So that's a big one. High vapor diffusion. Now this was one of my favorite things, because usually when you get something like styrene, for example, yes, it's a very good insulator, but is not breathable at all. This has high vapor diffusion, which means, although it has all these wonderful insulative properties, it will still allow vapor to diffuse. And as building biologists, breathability of materials and buildings is critical. So the fact that this is vapor permeable and has high vapor diffusion, is the term used, is a very big plus. James did a wonderful experiment where he took an insulation bat, polyester or rock wool and so on, and soaked it in a bucket of water, and then lifted it up and you see the soggy revolting like a wet towel, and then did the same thing with one of these panels, and it was still fairly rigid. Now it's a bit of an extreme experiment, but it just goes to show that this can deal with a hell of a lot more moisture without having issues. So if there is a leak and whatever, this will help to deal with it a lot better, and it will vapor diffuse a lot better, so that water vapor can diffuse and not just sit and rot and break down this product. So all in all, wonderful products. Important to know that there are two different kinds: the more flexible insulation bat, as well as the much more rigid board, if you will, but both are there for insulation. I love the board. I think it should be used as much as possible, but the insulation bats are wonderful too. But if possible, this is a very good option in terms of insulation.